Hi, my name is Everett Taves. I'm a senior developer at Rackspace and Docker Captain. I'm here helping MC this Docker deep dive track, Docker deep dive track today, along with.
Hi, I'm Nathan Leclerc, and I'll also be emceeing. I'm an engineer at Docker Inc. We're going to dive really deep today. Are you guys pumped to dive deep? There we go.
And come on and move forward. If you're in the back, there's lots of open seats up here, lots of space, and the choice end seats, so you don't have to walk into the row.
Those are my favorite.
So let me introduce one of our speakers today for talking to us about building a secure software supply chain, Vivek. Now, it's kind of funny. I was surprised to learn that Vivek actually works as a senior product manager for Docker Enterprise Edition with Docker Inc. That's the surprising part, because I've been following you for like the past 15 years in your career as singer and beatboxer, a cappella. Can you spit some mad beats for us right now?
All right, let's do it. Woo! Vivek, I just learned something new about you. I had no idea. I hope that's not recorded.
Don't worry, I just took a picture that will immediately hit the internet. So, in addition to Vivek, we also have product manager at Docker Inc., Patrick Devine.
Hi, everyone.
His special talent is he can solve a Rubik's Cube in under a minute, but unfortunately we didn't bring one with us to show you, so you're just going to have to ask him to do it for you after the show.
Yeah.
And we'll be leaving about 5-ish minutes at the end for questions. We'll have mics, like these mics here, actually up front, sitting on the chairs. If people could come up to the front to ask their questions so we can capture the audio for the recording later. And that's everything. So take it away, please.
Sounds good. Hey, how are you all doing tonight? Today, this morning. All right, so my name is Vivek Saraswat. I'm a product manager at Docker, but I play an ops guy in keynotes. And
I'm Patrick Devine, also a product manager at Docker.
So we're both on the Docker Enterprise Edition team. So today's talk is about Docker Enterprise Edition, EE, building a secure software supply chain. So let's get to it. So here's the agenda of what we're going to go over today. We're going to start by giving a quick overview of what Docker Enterprise Edition, Docker EE is, the value propositions and features it provides. Then we'll go into an architectural overview of what the Docker EE cluster and deployment looks like. And finally, what we thought we'd do is we went over some cool features in the keynote today, but it went pretty quickly. So we thought we'd slow down and deep dive into some of those features that you saw in the keynote. This is both features that are currently in the product, as well as some that are coming up pretty soon. So we'll deep dive into them, take a look at how they work, and then show how you can use them, plus a pair of demos. Patrick will give an image management demo, and I will give an app deployment demo. Does that sound good to you? All right. I like that enthusiasm. All right, so what is Docker Enterprise Edition, EE? It is a containers as a service enabled platform for the modern software supply chain. What that means is it allows your devs to run the containers that they want to run while providing ops with the control and management that they need in order to run that platform. Consists of a couple of different things: integrated orchestration, security, and management. These are the features, and this is what allows you to build a secure software supply chain. It's a predictable quarterly release process with a 1 year of support and maintenance. In that 1 year support window, all security patches and hotfixes are backported to those supported versions. There's enterprise class support, both same business day, 12 hours by 5 days, or business critical, 24/7, 365. And in addition to the features and support in the platform, there's certified infrastructure containers and plugins. So Docker Enterprise Edition is its own platform. Underneath it, it runs on a variety of certified infrastructures. This is OSs such as RHEL, Oracle Linux, Windows Server 2016, Ubuntu, SUSE, CentOS, as well as cloud platforms like AWS and Azure. It also runs, importantly, on-premise or in a virtualized on-premise environment. On northbound of the actual architecture, you have the certified plugins and certified containers. So certified plugins are things like storage and networking, connecting to your backend arrays. And certified containers are applications from partners that you might run on your environment, things like monitoring and logging, for example. So that's Docker EE in a nutshell. So there's a couple of different editions at Docker split into two categories, Community Edition and Enterprise Edition. So what's the difference? Community Edition is really the free do-it-yourself option for dev and ops. It doesn't include support. It does have a quarterly stable release for ops. And it also has this monthly edge release for developers. So for developers who really want to move fast and check out the newest features, they can use the CE edge release. EE is really what we recommend for production use. This is the paid Docker subscription, includes support as we talked about, predictable, stable release pattern with hotfixes, that certified partner ecosystem, and then enterprise-grade features in areas like security, management, and automation. So again, that's really the prod use that we recommend. So what are the various components of Docker EE? It all starts with the Docker engine that you know and love. This is the EE version of the Docker engine, which has container runtime, orchestration in the form of swarm mode, networking and volume through the use of plugins. So that's the basic Docker engine that runs across each of the nodes in your servers. For image management, this is where, again, as we talked about in the keynote, where devs store the images they create and ops pull those in order to run in the prod clusters. That's Docker Trusted Registry, which Patrick will be talking about. For application and cluster management, when you actually want to run those apps and schedule them against a cluster of nodes, there's Docker Universal Control Plane, and that's what I'll be talking more about. So all of this runs on either in the public cloud, AWS, Azure, et cetera, runs in virtualized environments like vSphere, or it runs in physical bare metal environments. The point being that you own the nodes and you control them and download the software and run them on those nodes. And finally, there's several northbound pieces that fit into this, whether it's CI/CD platforms, different images, operating systems you run, volumes, monitoring, logging, and so much more. So let's talk a little bit about what the Docker EE architecture looks like. It all starts with the manager nodes. These are the ones that actually hold the state of a cluster, that do the scheduling. For UCP, Universal Control Plane, you can have one manager in a test dev environment. For prod environment, we'd recommend a high availability configuration. So that's 3, 5, or 7 nodes. And this is, again, where the actual state is stored. Now, when you're deploying your applications, you're going to run those on worker nodes. Now, you could, in a test dev environment, run the workers and managers workloads together. But in a HA environment, we'd recommend that you separate your managers and your workers. But again, these are where your applications will be run and deployed. Finally, for the images are stored in Docker Trusted Registry, or DTR. DTR similarly runs on a series of nodes that are connected up to UCP. Now, you could also run it in a one-node test dev configuration, or you can run it in HA, similarly 3, 5, or 7, with so-called DTR replicas. And this protects the management plane for DTR. So this is the Docker EE architecture, UCP managers, UCP workers, and DTR replicas. And then there's add-ons you can have in addition to the cluster. So monitoring and logging solutions, a backend LDAP or Active Directory instance to authenticate your users, external CAs of your choice depending on your company, and then the backend that you're using for the image storage. And Docker EE is available in 3 versions, and putting this so you can see some of the name changes we've had. EE Basic is what used to be called CS Engine, or the commercially supported engine. So this is the basic Docker daemon in a supported hotfix patched capability. And it also includes the certified containers that we talked about before, certified infra, certified plugins, as well as the business day or business critical support. EE Standard is what is known as Docker Data Center. So this adds on top of the engine Universal Control Plane and DTR for application management and image management, respectively. Along with UCP and DTR, you also get various security features. So role-based access control, Active Directory integration, as well as things like integrated secrets management and image signing and policy. And finally, EE Advanced includes advanced features such as the Docker security scanning and continuous vulnerability monitoring that we showed in the keynote demo. So let's dive into the keynote demo features. I'm going to turn it over to Patrick, who's going to talk to you about image management.
Great. Thanks, Vivek. So like Vivek said, I wanted to just kind of do a little bit of a deep dive on some of the things that you just saw a little bit earlier this morning. And in particular, I wanted to deep dive on image promotions, which is the first time we've shown that, and also into image scanning as well, too. Okay, so what is image promotion? At its base, really what image promotion is that you're blessing an image which you've pushed into one repository from one place into another repository. Maybe that's from dev to QA, or from QA to prod, or kind of any intermediate steps that you might want to do as well. And it's also having access control on each of those things. So maybe you don't want your devs pushing to QA or to prod or some other place. You just want them pushing into the dev repository. And as a process of doing that, you can also retag it. So say you have like a build number or something that's coming from your, I don't know, like a Jenkins build server that tags it one way, then it gets promoted or it gets pushed into your Docker trusted registry. We can actually, as part of the promotion, change the tag as well too. And you can do this manually, like maybe you have a person who's kind of like the arbiter of who says what goes to prod, or you can actually do it through a promotion policy. So that's the automatic way of having it actually promoted from one place to the other. So this is kind of the use case, like a really simple use case that I kind of just sort of explained. But you'd have a build server. The build server would be something like Jenkins. Jenkins is going to build an image. In this case, it was just dev hello world. We tagged it 3421. Maybe it's some random build number. It gets pushed into the dev hello world repository inside of Docker Trusted Registry. And then as the next step, step 2, there's a promotion policy that would happen at that point and would automatically promote it into the QA hello world repository. And retag it at the same time as well too. And then the access control is different. So what are some of the different criteria that you could have used to set up one of these kind of automatic promotion policies? So you could have tagged it a certain way. You could have used image scanning, and maybe you didn't want a vulnerability that was inside of that. Maybe there is a package that you don't want to exist in, somehow someone slipped it in, or maybe you actually wanted it to be at a particular, you did want that package and you wanted it at a specific version or greater or less than a certain version. Maybe you are concerned about size. I don't know if you have like Apache, Tomcat or something like that, or a Java that goes into your image. And you don't want those bigger than a gig. Maybe you want to gate on that. And if you're developing commercial software, you can, I mean, sometimes you don't want to mix incompatible licenses as well too. So we can actually scan for GPLv3 code and things like that, where we can make it so that it won't actually promote from one repository to the other. So you can also chain these together. So I showed you in the first example, we went from dev to QA, and we set up some access control there. But you can chain these together, so you can go from dev to QA and then on to prod. And these are kind of arbitrary. You can set up as many of these as you want. We retagged it there as 1.0 as well too from the other ones. So. But you can also, not only can you do these kind of chains, you can also branch as well too. So it's called almost like the like an anti policy, where we've got the normal production flow where everything's good and there's no problems, but we could have also made effectively like a sin bin, where if we detected one of these vulnerabilities or something like that, we could send it to that other place, and it gives you a lot more visibility into that repository, so you can see what's gone wrong. And I've been talking a lot about image scanning, so I thought I would go a little bit and kind of give you a little bit of behind the scenes of what's going on there. So the way that we do image scanning is a little bit different than some of the other image scanners that are out there right now. We actually do it at a binary level, and we're not just looking at like a package database, like an RPM database or your app cache or whatever. We go into the file system. We look at each one of the binaries that are sitting inside of each of the layers that you've got, and if someone is compiled in or statically linked in a particular library, we can actually go in and figure out whether that is actually sitting there or not. So it's a little bit different than some of the other solutions that are out there. So it works online and offline, and we release new copies of the vulnerability database daily, and you can have it if your Docker Trusted Registry is attached to the internet. We'll go and you can have it so that it will update every day. But it also works offline as well too. So if you've got, I don't know, you're in Antarctica or on a cruise ship or in some kind of secret military base, and you can't have access directly to the internet, you can actually download these separately and kind of sneaker net them into your Docker Trusted Registry, and still be able to make sure that your images don't have things like critical vulnerabilities. And it works today in Linux, and actually in our upcoming 1706 release, we're also going to be doing it for Windows as well too. So I want to talk a little bit about how things work. So the first thing that we do when you push an image to Docker Trusted Registry is that we actually take the individual layers that comprise an image, and we then kind of start introspecting inside of those. And we generate this thing called the bill of materials. And that's the part where we're doing that binary scanning through each of those layers that checks to see what's in each part. After we've got that, then we actually apply the bill of materials. We take a look at the vulnerability database that you've got, or that's been updated daily, and we actually start filling in that bill of materials to see what are the things that are actually broken. I'm going to go a little bit more into each of these steps once it's done. Once we've done all that, of course, the scan is complete. And so when we go to get each of these image layers, it's effectively the same thing. If you were to use Docker history to go and look at one of your Docker images, you can see effectively each of the things that were used inside of your Docker file to build this particular image. And that's really the same thing that's on the left-hand side of the view inside of Docker Trusted Registry. And in this case, there's a vulnerability that's been highlighted in one of the layers. And that's exactly the same thing as what's inside of our Docker file. And you can just go and update it and push again and be able to find out where the problem is. So when we go to generate the bill of materials, that's really just a JSON file. So once we're doing that scanning inside of the image, once we've picked everything, this is kind of like a long-running process. It takes it a little while to run, but once it's completed, it fills out the JSON file with each of the components that we found, and then we just fill it out. And that's where we apply it to the vulnerability checker. And then once you have each of these images, if you're doing builds that are building on top of each other where you use the same layers over and over again, we can reuse all of the layers that we've already done these scans for. So the subsequent image scanning gets to be pretty quick. It is a little bit of, since we're doing that binary scanning, it can actually take a little bit of time. So it's a really good practice to build on top of your existing images. All right, so I'm going to do a quick demo. Wouldn't be DockerCon without a demo, right? So let's go over. Hopefully everyone can see that. So I've got a little application which I put together. It's the Party Parrot application. And what I'm going to do is set up a bunch of promotion policies here. So I'm going to push into the Devine Party Parrot repository. And then what I'm going to do is I've created two other repositories, kind of the sin bin, that's the Party Parrot bad. And I've also created this Party Parrot prod, which is going to be my production repository. And I'm going to set these up by going through the API documentation. So everything in Docker Trusted Registry, we've got online API docs. So anything that you see inside of the UI, you can also do through the API as well too. And I'm going to scroll down here to our promotion policies. And I'm going to post to a new one. I'm going to call it pdevine. It's the Party Parrot repo. I'm going to copy the schema. And so you can see this rules section here. You can set up as many of these rules as you want. In this case, I'm going to do vulnerability critical. And I'm going to set up the sin bin first. So if it's greater than 0, then what we're going to do is we're going to promote to that bad repository. So pdevine Party Parrot bad. And what we can do is we can change the tag as well too. So this is just a really simple template. I'm just going to use the same label that was in there before, but there's a whole bunch of different things that you can use here. So I'm going to just make it year, month, day, and then we're going to say bad on the end of it. And hopefully if everything worked correctly, I can click try it out. It should give me a 201, which it did here. So let's set up, that's the bad one. So let's set up the good one now. So here we'll just put EQ 0. So vulnerability critical equals 0. Just make sure I spelled everything correctly there. And we're going to send that to prod instead. And we're going to say that it's good. All right, and that should have worked. We've got 201 as well. And now we can actually go and look at inside. We've got this new tab here, which is policies, and we can see that we've set up the 2 policies. And you can kind of go through and see what each one of those are. Now let me flip over to my party parrot directory. Now normally, of course, you'd have Jenkins, and you're pushing to Jenkins and doing all the other good stuff for CI. But in this case, what I've done is I've just set up some stuff in here. And we're going to just say make Docker, and that's going to create us a Docker image, and then we're going to tag it. And we'll tag it as 1.0. And then we're going to do the push. Okay, that looks like it worked. We're going to come back here into the repositories, and we should see images. It looks like we actually have some vulnerabilities that are in that. So let's go and check to make sure that the promotion policy worked correctly. And it looks like it promoted. So you can see here that it retagged it with the new tag. It gave us the promotion label there on the side. And then there's a bunch of vulnerabilities. So let's go ahead and click into here. And you can see, again, on that left-hand side where there's actually a vulnerability. It looks like someone put in the PCRE library. I think it's the Perl regular expressions library. So looks like there's a bunch of problems with it. You can actually see each of the CVEs for it. And then if you were to click on any of this, it would actually take you to the NIST database, and you can see what all the problems were. Let's go and fix that really quickly. So let me reset this. Oops. And we should be able to look at the Docker file because we knew where the problem was. It looks like someone added this particular line, so let's go ahead and get rid of that, and we'll do make Docker again. And we'll retag it. Let's make sure we get the right tag. We'll call it 2.0. And then do the push. Make sure we push the right one as well. OK, it went. And let's go back. We'll take a look at our repositories. Here's our images. Looks like it's good now. And let's just double check to make sure that the promotion worked correctly. And there it is. So it retagged it with a new tag that was different from the other ones. Said it was promoted, and it's clean. So I'm going to turn it over to Vivek to talk a little bit about the universal control plane.
Thanks, Patrick. All right, so let's dive into the Keynote demo features. And apparently I forgot to insert a picture of the Keynote here. It's all good. Work in progress. So I'm going to talk a little bit about application and cluster management, building on the image management features that Patrick discussed. So we're going to talk a little bit about hybrid Linux Windows, something that we showed off in the keynote, as well as apps with secrets management and the features that Docker EE provides for secrets management. So what exactly does a mixed Windows Linux cluster look like in a Docker EE environment? So similarly to what we showed in the keynote, you have your UCP managers and you have your UCP workers. The managers are running Linux. This includes UCP controllers. It also includes the DTR replicas, as well as shared security services such as authentication for Active Directory, the image scanning service, or things like notary signing. So that's all going to sit on the Linux managers. The actual application workloads themselves will run on the mixed workers. And as we showed in the demo, you can have both mixed Windows and Linux nodes running on the same cluster. So the Windows containers will run on the Windows nodes, and these are very specifically Windows native applications running on those Windows nodes. And then the Linux containers will run on the Linux nodes. That's kind of how the deployment will look. And as you may have heard in the keynote yesterday, Microsoft is working on bringing Linux kernel to Windows. Once that happens, we'll be able to run some of these Linux managers directly on the Windows nodes as well. So what is a hybrid Linux Windows app deploy? So it's cool that you can deploy separate applications to the Linux and the Windows nodes, but can you actually get them to talk to each other? The answer is yes. So an example here is a compose file, which shows that you have both a Microsoft SQL Server database as well as front ends in Linux. And you can use labels and constraints in order to schedule intelligently. And I'll walk through the compose file in some more detail. And there are some inter-OS networking considerations to take in mind. Just make sure that the two operating systems can talk to each other on a certain level, and you're good to go. And I'll walk through the compose file when we get into the actual demo. So the next thing I want to talk about is secrets management. And this is something that's in the product today. So the use case is pretty simple. You have an application, and you want to provide that application with a secret, or with something like a database password, say CAs, a list of authenticated users and their credit card accounts. And you want to make sure that only that container can see the secret, nothing else. Only that application should be able to see that data. Now, you could do something like put a host-mounted volume, but if you do so, that could mean that every other application on that host will be able to see that secret piece of data. So how do you get around that? That's where the secrets management feature comes in. It starts with securely storing a secret, generating it and storing it on the internal distributed store within the UCP swarm managers. So you create the secret, and the secret is only visible. Once you've created it, you can't see the value until it's injected into a container. Then you go ahead and you inject it into a service, either at runtime or as a service update. And you designate a folder, such as /run/secrets/foo. The important thing is that this folder then appears on that container and all the container tasks within that service, but it's in memory. It's a tempfs volume in memory, never gets saved to the actual host itself. So it's an added layer of security. The other thing to consider is, let's say you have a couple of different applications, each with their own secret. How do they connect? So here you can see we have the red container has the red secret, the blue container has the blue secret. The two cannot see each other, fundamentally. However, let's say you have an external application that you want to actually get the secret from the blue container. So the case is, if the application has network access to the container, then it will be able to access the secret. So that's how you can ensure, as long as you have access, the container can see inside the file system, you're okay. But if you don't, you're not allowed to touch it. So secrets is a pretty simple workflow for both dev and ops in the EE product. For devs, you can either, in the UI or the CLI, add secrets with a Docker secret create that adds it to the actual Swarm RAF store. Or you can inject a secret into a service. So Docker service create -s secret equals foo. You can also use a Docker service update to do the same thing. You can also define services, secrets, networks, and volumes in a compose file in YAML version 3.1 or higher. Docker EE adds a couple additional features for secrets on the ops side, and it's really about management and control. So for management, there's a full GUI where admins can add, remove, list, update all the secrets in the cluster, and it's really easy to see which services a secret has been attached to. But the other really big feature is authorization. So using the existing role-based access control mechanism within UCP and Docker EE, admins can authorize which users and teams of users have access to a specific secret, and what level of access do they have. Can they actually use it? Can they view it, etc. So that's a powerful way that you can ensure that only the users that you want to access a specific secret in a specific application are getting what they want. You can also do some fun things like rotation, use the GUI to update a secret to all containers in a service with a rolling update. Say you want to switch out a cert, for example. Or auditing. So UCP has a built-in syslog feature which runs through all actions taken against the cluster. So this applies to secrets as well. Each user request to get a secret, or each admin attempting to say you're allowed to granting access to that secret, that's all logged in using syslog. So you can send that out to an elk stack or your logging platform of choice and get a sense of who's trying to do what in the cluster. So I've talked a little bit about access control. What exactly does that mean? Well, it's just the way that you can lock down your cluster. It's about who has access to what resources and what level of access that they have. So it starts with who are the users. That's user authentication. So in UCP, you can either create and manage users directly using the platform. It'll be saved to the RAF store. And DTR and UCP will share those same set of users. Or you can use a backend LDAP or Active Directory platform, grab your users in and sync them. Once you know who your users are, it's really about granular role-based access control. So you can put those users in a series of teams and orgs, and you can assign them certain permission roles to specific applications. It runs the gamut from no access, I can't see anything, view only, I can inspect, I can LS, but I can't actually change anything. Restricted control allows you to create and delete containers and run containers. Full control gives you a little bit more security-related things like being able to exec into a container or host-mounted volumes, kernel access. And finally, you have the admin who can do pretty much whatever they want. They can see all containers, they can manage user permissions, and change UCP settings. So combining access control with things like secrets, you really get that picture of who has access to what and how much access do they have. So now I'll do a quick application management demo. And I didn't make a sacrifice to the demo god, so we'll see how this goes.
We didn't have a hat rack.
So this is the, I'm going to switch over. This is actually the same cluster that we were running in the keynote. And I'm going to take a little more look into it. You can see that it's already running Docker Trusted Registry, Docker Universal Control Plane, and the Art Store application, so the one we showed in the first keynote demo. And if you take a look at that, you can see it consists of a couple of services, database, application server, payment gateway. And the database is Microsoft SQL Server. That's running on Windows. The other two are both Linux-based. So let's take a look at how that actually plays out. Again, you have, I'm going to sort this easier by OS. You have two Windows worker nodes here. Again, they're running Windows Server 2016, which is the build that supports Docker containers. And if I click into one of those nodes, if it clicks in, then I can see Microsoft SQL Server is running as a container there. If I go over to the Linux nodes, as we showed before, there's two Linux workers here. I can see that the payments gateway, that's Etsy payment, and the Enterprise Art Store are running on that same thing. And just for fun, this is what the Enterprise Art Store looks like. I love this one. Okay. Importantly, we have a couple manager nodes, but we set up in the cluster such that the worker nodes are the only ones which applications can schedule against. That's a quick setting that you can set within UCP. So I'll show that. You can control only, you can allow admins or users to deploy workloads to the manager nodes or to DTR replicas. But by default, it's set up that your managers and your workers are separate, which is what you'd expect in a production environment. Okay, so let's also quickly walk through what the compose file looks like so you can get a sense of that. So we showed this before. This is the database. The important thing that you want to note is the constraints. Node.labels.os == Windows. And here on the app server, you can see the same thing except == Linux. So why do we have manual constraints for this? Let's say you have an application that's a fat image that runs on both Windows and Linux. You wouldn't want to set specific, you wouldn't want it to automatically say just schedule to Windows or schedule to Linux or a fat application. Let's say we move to a variety of different infrastructures. By setting the actual node labels, you have much more control over which nodes you want it to go to. Maybe you do want a fat image to only go to Windows because that's where your prod use case is. So using labels allows you to set very quickly, set the constraints around your cluster, what should go where, and it can also be used for security purposes. And then at the bottom, you have the overlay network that connects these. So the overlay networks run across both the Windows and the Linux nodes. And then the secrets that you injected in, as we discussed. So that's basically how the Windows side of it works. I want to do a quick demo of access control and secrets management as well, so you can see what it looks like. So let's go back to the Resources tab, and let's go ahead and go to Secrets. We're going to create a secret. So let's call it My Secret, and give it my also favorite password. So that's the secret. Now, you see this thing saying permissions label here. I'm going to assign it the prod label. So this is what allows me to determine what users have access to this application. I'm an admin right now, so I can do whatever I want. So I'm going to assign the prod label to it. Now we're going to hit create. You can see here that the secret is created. If I go to services, there's no services attached to this secret yet. And importantly, I can no longer read the actual value of the secret. Once it's created, only the application that gets it can read it. And that's for security reasons. So okay, we have our My Secret. Let's go ahead and create a really simple service. Let's go ahead and create, say, Postgres. So first things first, there's a permissions label here, but I'm not going to touch that for now, and I'll show you why. I'm going to go to scheduling. I'm going to add the constraint to make sure it only runs on the Linux nodes. I think that's correct, I think. And then finally, I'm going to go to environment, and I'm going to inject the secret. So you can see here, as an admin, I have access to all of these. I'm going to click My Secret. It's going to go to the /run/secret/mysecret directory by default. And I'm going to hit done. OK, looks like we're good to go, so I'm going to go ahead and deploy. Nope. So in order for a service and a secret to work together, they must have the same permissions label, permissions requirements. That's to ensure that if somebody has access to one service, but they don't have access to the secret, they can't just put them together. You want to make sure that the right things are connected. So what does that mean? Well, since I'm an all-powerful admin, I'm going to go back to that permissions label, and I'm going to add that. So now when I deploy, it should work. And we have the Postgres service. And if I go back to that environment tab, I can see that my secret is here. But OK, let's say we actually want to see the value of that secret. Well, where is it stored? So let's go to one of the tasks that are running. This is the Postgres task. And this is the individual task within the individual container within that service that's running. Now let's go ahead and go to the console. So I can, in UCP, actually exec directly into a container. So now we're inside the container itself on the file system. So I'll ls quickly, and let's go to the cd run directory. And here you can see that there's a secrets directory as well. So I'll cd into the secrets directory. And there's my secret. It's right there. So what's the value of that? There you have it. So only, again, when you're inside the container can you actually see the value of that secret. And none of the other containers on that host are going to be able to touch it. But where else does access control come in handy? Well, let me log out for a second. And I'm going to log in. I'm no longer a powerful admin. I am lowly user Vivek. And this is my view of the cluster now. I don't have any permissions set up on this user. So let's go ahead and go to services. I don't see anything. Let's go ahead and go to secrets. I don't see anything. By default, it's secure. Because I don't have access to anything, I'm not granted access explicitly, I cannot see anybody else's things. I can deploy my own things, but nobody else will be able to see them except the all-powerful admins. So this gives you an example of how you can use access control to lock down your cluster. And that's it for the demo. So in summary, what have Patrick and I showed today? We showed Docker Enterprise Edition, which is a container management platform with support from Docker and integrated orchestration, security, and automation features. We talked about a couple of different Docker EE features. A couple of them are available today. So image scanning and secrets management are both features available on the platform today. And a couple are coming soon in the next release, 1706. Image promotions on the image management side, and Linux Windows clusters and apps on the on the UCP side. So we encourage you to try out Docker EE for yourself. You can get a 30-day trial at docker.com/trial.
We're doing some demos down in the booth as well too, if you want to come take a look on the expo floor.
Yep, come to the booth, and that's all we have. So you can find me at the V Saraswat. You can find Patrick at pdev110. Happy to take questions. Thank you.
So we'll do about 5 minutes of questions now. Before you take off, I do want to encourage you to vote for the session in the app. Tomorrow, all the top-rated sessions that you have voted on are going to be repeated for everyone else, so everyone gets the very best of the best at DockerCon. And now if you'd like to ask a question, I'd encourage you to please come forward. There's, if you're closer on that side, there's a mic on the chair up front here, or you can use this one.
I'm sure you probably hate ETAs, but I gotta ask, when do we get to see the hybrid cluster?
Sorry, I couldn't hear very well.
I know you probably hate the ETA, but how soon can we see the hybrid cluster?
Yeah, so it's targeted for the next version, which is 17.06, so that would be the June release.
Cool, thanks.
Hey guys, great material. First question was just around the slides. Are they going to be on GitHub? And second question was more low level about the scanning. Just wondering how that works. Is it based around hash values? Is it hashing all the files and then checking those? And then like the database that's actually checking against, how is that built and checked against?
So I'll take the first question. I think the slides will be posted after the sessions. Might be able to help us with that. They'll be available through DockerCon. So slides will be available.
Through the app or?
What's that?
Through the app?
I am not sure exactly how it works, to be honest, but they usually post them on SlideShare or something like that afterwards.
Okay.
But yeah, you want to take that?
Yeah, so in terms of the image scanning, I believe that I'm the product manager, so, so I believe it is going and looking through each of the hashes, but it does do a deep introspection into each of those binaries and is able to figure out like signatures inside of it and then is able to surface those in.
And then are you guys scraping like the MITRE database for CVEs? Like how do you update your database that it checks against?
How do we update the database?
Yeah.
Yeah, so we have people that are actually going and actively looking at these vulnerabilities, and then that's how we update our database from that.
Okay.
So yeah, we scrape the CVE databases and update on Docker Store, I believe.
We'll take another question over here.
Okay.
Yep.
Thanks.
Thanks. I have a question about the node labels. You mentioned that they can be used for security purposes too. The node labels, that they could be used for security purposes, does that mean that it's possible to restrict placement for specific nodes so that only users with certain permission roles will be able to deploy containers to specific nodes?
Yeah, so that's actually something we're working on right now. In the current version, you can use it as a constraint to only schedule. Enforcement is a bit of another story, but that's actually a feature currently in development.
Can you give just a quick idea about how that's going to work?
So the idea would be similar to the way that you see access control today, right? You assign a label to or you assign a permission, a role to a specific resource group, which a label represents. You can imagine today nodes is not a part of that, but in the future it will be. And so you say, I have my prod group, and these nodes are in it, and only my, my production engineering team has control to those nodes. Whereas, say, the business guy team like me gets view-only access. You can't actually schedule anything, or you can't even see those nodes at all.
Cool. One follow-up. I saw the word multi-tenancy mentioned. What multi-tenancy? I saw that mentioned as part of what Docker EE does with Docker Data Center. How is this to be understood?
So multi-tenancy comes in a couple of different forms. There's logical isolation and physical isolation. So the current access control mechanism provides logical isolation. Two users cannot see each other's applications, though those applications may be residing on the same host. The node access control provides a physical isolation. Yeah.
Thanks.
Hey, so I've got Docker Data Center with Linux nodes right now, and I'm curious about adding Windows nodes, but wondering if you could just say a few words about licensing and what I would have to do that.
Yes, honestly, that's still being worked out, but the idea is that, at least the idea I understand today, is that the same license that you use would be valid for Windows or Linux nodes. Now, it doesn't necessarily include the Windows Server license, that's obviously Microsoft's thing, but the Docker E subscription would cover both.
Thanks.
Yeah. Like a node is a node, effectively. Yeah.
With the hybrid clusters, when you have a Windows node and you're assigning the images that get run on there, how do you control whether it's running in a Windows image or a Linux image on the Windows node?
So you're saying if the repo consists of two sets of images?
Do you mean if it has the same tag on both, and then does it pull the correct
No, I'm saying like the Windows node, it's either in Windows mode or Linux mode.
Oh, yeah. Yeah.
How do you know which one it's in when you're assigning where it runs?
I'd have to deflect to. Yeah, so like
Just real quick, I think you're kind of asking about the keynote and the demo that Microsoft gave about showing nodes that could run both Windows and Linux on the same node. That's still stuff that's work in progress. That's not actually out in the field yet. So today, with what was demonstrated here, essentially a node is either Windows or Linux. It's not both. And so from the perspective of the cluster, we see it as a Windows node or a Linux node. And so we can make scheduling decisions based on that.
I've got a question around the secrets. So we say I've got an existing password management system. Do you guys expose an API so I can create secrets that can be used within the Docker data
So are you
center?
asking if the secret is stored in the
some external system, some old password management system that we're building a lot of our legacy apps around? Is there a way to expose an API that we can then inject secrets that could be used?
So the secrets API is part of the standard Docker API. So you can use the Docker API to inject the secret, but the secret will be stored on the Swarm cluster.
That's fine, but if I'm creating the secret and passing it through...
That's right, that should work no problem.
Okay, thanks.
So we're officially at time here, but because it's the pre-lunch session, we do have a little bit of space. So if you gentlemen would like to take more questions, that's fine. If you'd like to move it down to the floor here, that's fine too.
We can move it down. We have a bunch of the engineers from the team as well here too, so we can.
Yeah. So if you've got some more detailed questions, come on up, ask the team, and find out a bit more about Docker EE. Thanks, everyone.
Thank you.
Thank you.